Welcome back to Uncle Fish. Today we are going to talk about strings in C++. If you've been following along, strings will be really easy to understand if you understand some of the other topics that we've kind of covered already. One of those topics is data types, and then the other topic is arrays. If you understand these, if you don't understand these, then I highly recommend you review the video on data types and variables. And also on arrays, as then this will make understanding strings really, really easy. All right, let's get to it. So let's first start with data types. So char is a single byte character, meaning that it takes up 8 bits of space. And earlier on there was a standard, an ASCII standard, that basically had an encoding for about 256 different characters. So alphanumeric characters along with some punctuation, and they were all single bytes. So that's good for singular individual characters, but what if you want to try to make a word or a sentence, right? And that's exactly what strings are for. Strings, and judging just by the name itself, is really a string of chars, things strung together basically, okay? So a string essentially is, under the covers, an array of chars. And that's it. Now, one thing that's special, though, about this array that's different than other arrays is that at the end of this array, there's a special character. That's an awful backslash, but it's \0. And this is referred to as the null character, or null terminator. Terminator sounds pretty like Terminator. All right, so that's the uniqueness, right, of this string, is that at the end of it, it always has this null character. So don't be confused if you've heard null in other contexts, null almost meaning empty, but in this particular context, null is actually talking about this null terminator. So let's look at one as an example, and hopefully it'll make a lot of sense. So what we'll start with is talking about how to do this in the original kind of C way, C meaning C the language. So in C, we would do something like this. We would say char, and like my string, and you could literally give it a size, right? So we'll say 6. Okay, and what is this really doing, right, under the covers? Under the covers, we are allocating in memory this contiguous block. And again, if this is not making sense, that this is an array and it's a contiguous block, then I highly recommend to go back over the array and vectors videos, okay? So you get this contiguous block of memory, and we are asking for 6 spots. 1, 2, 3, 4, 5, and 6. And contiguous again, side by side. And the fact that we're asking for char, remember that's a single byte. So we know that each one of these spaces is 8 bits. And we use that and pointer arithmetic to move along the array in this case. Okay? So if I were to say, for example, char my string and initialize this guy right away using like hello, you might be wondering, why would I allocate 6 spots if I wanted to go and put in the word hello? Well, so remember about the null terminator. So what's really happening in the string is HELLO, and then the, let me do it ugly, \0, right? Null terminator that gets put at the end. If you were to, for example, do this with 5 and then go try to set, hello to it, it would not work. You would get an error or just undefined behavior because it would be an overflow. Okay, so this is how it was done, let's say in the C world. And when we look at like C++, we get to take advantage of the things that other developers have done for us, right, to make our life easier. So in C++, you will get a string class. We haven't really covered classes just yet. We will cover them in future videos, but for now, just think of them as some, like an object. I guess even that's a little confusing. But just think of it as something that's that you can call and use for different things. It gives you some functions and it gives you some attributes. But again, we'll cover those a little bit more in detail. So in the C++ way, in the standard library, std : right, string, we would say, let's call this our C++ string. Okay, we would again initialize this and say hello, right? Just the same. Semicolon. Now, one of the things that you're kind of getting here for free is notice that you did not have to declare any kind of an array, but under the covers, it actually is allocating just the same, another array, and it's putting in hello into that array, and it's putting in the null terminator just the same. But the benefit of doing it this way is you get a lot of cool things with string, the class. You get other functions, like you can go look at the size of it, you can look at the capacity, and again, those two terms are much more about arrays than they are anything else. And so if that's confusing, go back to the arrays video and then come back to this, okay? But you'll get things like being able to sort against them. You can go out and look at substring, meaning like get chunks of them, like, you know, the first two characters of a string or the last two or the middle three, whatever you want to do. So there's a lot of capability that the string class allows for us to do. And it's the best way to go show it, honestly, is to look at code. And that's what we're going to do next, okay? But in general, just from a theory or lecture perspective, that's really all what strings are, okay? Is a set of character arrays. One minor point to also think about here is, right, we talked about the char arrays. Well, char is, if you just look at it in very simple terms, was that single byte, but that's not enough, right? We have like Chinese characters, Japanese characters, like all sorts of different characters out of different languages, so char alone is not going to do it. There are other types of characters that you're going to have to account for, things that are encoded with Unicode. There's 8, 32-bit, 16-bit, so on and so forth. We'll cover those again in a later discussion, but you got to think about it not just in the context of English, okay? So think about it in the context of lots of other languages. And so those spaces that are really reserved in that array are not always going to be 8-bit, okay? They might be different size depending on what we have here. And it's really important to understand that, because then when you go do some of these functions like length and size and so on and so forth, you might get values that don't make a lot of sense to you. All right? Okay, so with that said, let's shift gears over to our code. Give me 1 second. And I'll bring that screen over. Here we go. All right. As we typically do here, we will go over the code. We will run the code together, and then we'll line by line it and look at the output and see what we were trying to achieve with the code itself. And as always, we ask, if you want to follow along, you should pause the video. I will provide this source code in the as a link in the comments so that you can go download it yourself. But I urge you to look through the code, right? Understand it a little bit, test yourself to figure out, like, hey, what is actually going to get printed out to screen, so that you understand the concept and like what's going on, and then come back and we'll go over it line by line. All right. So assuming that you have done that, let's go and run the code. So I already compiled this code, and I called it strings. So let's execute it. All right. So one of the first things that we did here at the very top was we declared a C-style array, or strings rather. And notice again, it's char C string with an array, but I'm initializing it here to hello Uncle Fish in the C. I just realized that I did that. It's pretty funny. And then here we're printing out basically that as a string here. So that's just this line right now. I wanted to give a representation of what this looks like in memory, right? So again, under the covers, like what's happening here, this is an array. So if I go through here and I loop through the array, what I'm going to do here, you don't need to know this code yet. We'll go over it. It's a little bit more advanced than this spot that we're at, but it's basically giving you that memory address, okay? And if you can follow along, this is an incremental thing that's happening here on these addresses. And it's sequential, meaning one next to the other, right? So that contiguous block. And you can see that we have hello Uncle Fish in the C, and then there's this thing that it doesn't know how to print here on Linux on my machine, but that is going to be the null character at the end of it. Okay, so this was again just to illustrate like what's going on under the covers there. All right, now we're going to look here to the same thing, and we're going to do it in the C++ way. So here again, hello Uncle Fish in the C++. And we will do the same kind of printing out of that particular object here and see what gets printed. Okay, so here we are. The address in this particular case is the beginning of this, wherever that object is. And I believe technically this is in the stack. And you'll notice that this is not contiguous to this, okay? And that the actual internal character array, which is here, that we're storing within that class, is at a totally separate location in the heap, very likely, okay? And when we look at like the size and the capacity, it's really much more talking about the array, right? And again, I've said it like this the third time now. If you don't know what that means, I highly encourage you to go check out the arrays video, all right? And the vectors one as well. Okay, so we're down to here now, and what we wanted to do is talk about some of the common ways that you can initialize the string. We mentioned a few, like in the old way there, where you can initialize it straight away, or you do it as an array and then go set each character separately in the C way. Looking here at C++, you can say string, standard string, C++ string 1, and then just initialize it straight away. Strings are my friend. CPP string 2. Basically, same thing. This is called, I think, a direct initialization, and this is called assignment initialization. I don't know, honestly, under the covers, like what's happening there, but there is a nuance here as to how they're created. I think one would be with the constructor, but again, I think it's too much for this particular point in the course. And then here you can say, I'm going to initialize a third one. I want it to be 5 lengths, and I want everything to be initialized with the letter A, right? So we basically showed like the different ways that you can initialize those strings here. We talked earlier about like the benefit that you get of using this class, and that's a bunch of functions and methods that come along with it. So we wanted to just make sure that we can go over those together. Please disregard my typo there. So one of them is length. So what we'll do here is we're going to say take CPP string and then print out the length. And you'll see here that the length is 21 for CPP string 1. So we can try to count this together, but that's 1, 2, whoops, that's the first letter, second, third, 4, 5, 6, 7, space, that's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, right? So this is the length of that particular string class. And if you see here, string 2, we're down here now. What we're going to show is how you can concatenate strings. So concatenation means like, combining two strings together, right? So what I'm doing here is saying string 2, this new string, I'm going to call it you wish with an exclamation point. And then I'm going to take string 1, which was strings are my friend, and I'm basically going to add to it this, right? And print it out. And so you'll see here on concatenated what got printed out. Let me move this over a little bit here. There we go. What got printed out here on the concatenated was strings are my friend, and you notice that the ... you wish was added at the end of it. Okay. Another function is substring. So the way the substring works is you tell it what place you want to start and how many characters you want to move to the right, basically, and substring meaning pull that particular string out of it. So let's go see that in action here. So CPP 1, substring 0 and 7. So CPP string 1 is this guy. We want to start at index 0, right? And then we are going to pull out 7 characters. So that's this first chunk here. And you'll notice that when I print that out, only the word strings gets printed out. And again, substring is a very powerful thing. You can do it in the middle, in the end, in the beginning, and you'll very likely be seeing this in your classes in school on leveraging some of these string functions. All right. Down here, what we're looking at is a way to find something. We can say, hey, within that particular string, tell me what is the index, right? Remember, it's an array. So what is the index of where the text my can be found? Okay, so what it will do is it will go in and search this particular string, and it will tell you where this my starts. So this is saying that my is starting at position 12. I don't want to count it again, so I'm going to let you count it, but it is starting at position 12. All right, let's see. Now, here we are, we're going to replace. So this is another function of the string class. So we're going to replace starting with 12. We're going to take over 2 spaces, meaning start at position 12, take the next two out and replace it with this. Now, you got to be really careful here with replace, because remember, this is an array under the covers as well. And so if you try to replace characters that are larger, you might get some undefined behavior with what was allocated. So just be careful, especially if you're using like the older style arrays. You definitely will run into some issues, right? So in this particular case, I'm saying take essentially the word my and then replace it with your, right? And we'll print that out here. So strings are not my friend, strings are your friend, right? You also can do append. So I'm gonna append, meaning at the end, I'm gonna put this exclamation point. So that's all I did here is just append a bang to it. Right here, I think this is on CPP string 2, right? So this is our strings used in string theory. And I put a question mark and now exclamation point, okay? And you can also do an insert. So here I'm saying take the string CPP2 and I'm going to insert at the 33rd spot this text, comma, and bro. And again, I'm trying to be funny. I know it's not that funny, but inserted strings is here. So our strings used in string theory, bro. I mean, that sounds pretty cool. And then here we are erasing. So you get the idea. Again, I'm starting at this 33 position. I'm going to take that word bro out because that's not really as cool as we thought. And so that's what the erase is doing here. Okay. And then down here, we're going to show like how you can compare string. This is honestly one of the most, I guess, confusing parts for students, right? They always get tricked up on this. Okay. So try to pay close attention here. So I have a string 1 called Uncle Fish, exclamation point, another string 2 called Uncle Fish, exclamation point, and string 3 called C++ rules. So let's see what this looks like, okay? This is the string object, and then we're going to do it also in the original kind of C way, which was with the character array. Okay, so here, C string 1 and C string 2, and again, it's Uncle Fish and Uncle Fish. So if C string 1 is equal to C string 2, then print out that they're equal. Otherwise, print out that they're not equal. So what do you think is going to happen in this particular case? So we are looking at these particular two things. They look identical, right? But if you look here, we should see C string 1 and C string 2 are in fact not equal. They look identical, but they're not equal. And the reason why they're not equal is because what you're really comparing here is not an array to an array. You're comparing the memory address of the array to the memory address of the other array. And they're not equal, so therefore they're not the same thing. It is not literally going through the array and looping through and finding each character and matching it, okay? So this is in the old way. Now we're gonna go do the same thing in the C++ way, right? So string 1, Uncle Fish, string 2, Uncle Fish. What do you think is going to happen here? Are they equal or are they not? So if you see string 1 and string 2 are equal is what gets printed out. And that's because, again, we take it for granted, but in the class, it has allowed for us to do that comparison under the covers, and it literally is going through the array and checking each one to make sure that they are equal to each other, okay? And there's something here called lexigraphically, which is sounds like a really complicated word, but lexicon is like a dictionary. Okay, so think of this as just like if you wanted to go see if you were trying to sort something, basically, right? Is A less than B? Is B less than C? So on and so forth. Okay, and so we wanted to show some examples of that. So is string 1 less than string 3? Right? So what do you think is going to happen? We'll see here what gets printed out. String 1 is not less than string 3, and the reason why it's not less than is because, again, U is greater than C, so it's not less than. So it's literally doing that kind of comparison as if you were to try and sort that. So one of the pitfalls of that is, so if we look here, for example, like some basic sorting of these strings, here we have a vector of strings called fruits, and we're going to use this function called sort. I believe that comes here in algorithm, so make sure to include that. But we're going to use this function called sort and say go in and sort that set of arrays, that vector of arrays that we created. Where were we here? Why did I lose my spot? Sorry. Whoops. Oh, here. Sorry. I apologize. All right. So we're right here. So we're going to go in and sort this, and basically what it's going to do is it's going to print out for us down here how we sorted those things, and you'll see basic sort, apple, banana, apple, banana, cherry, date, elderberry, okay? And so you can use these kinds of functions on string objects, and the string objects will automatically allow for you to sort them as well. All right. So the other thing though, one of the pitfalls that we run into here is when you look at those things and you think about like numbers and other things that are also being treated as strings here, how do you do that lexicographically, right? So is 110, so in this particular case, the number string 110, is that less than 2? Right? I mean, 110, what do you think is going to happen, right? So if we go off and print that particular thing out, down here, 110 is in fact lexicographically less than 2 because it treats it as a character. So 1 is in fact less than 2, and that's all it cares. It says, okay, on the first one, it's less than, so therefore this is definitely less than. All right? And again, another example of this is like, is 110, less than 1,000, right? And what you'll see is that it'll say 110 is not less than 1,000, when in fact 110 is absolutely less than 1,000. So all this is to say, you got to be really careful with how you want to treat strings when it comes to sorting and such, right? Because characters and numbers and such are going to get treated differently when you think of them lexicographically. All right? All right, so one of the last things that we wanted to show here is that we talked about that, thinking of the world not as just, single byte English characters, but to think about them as multi-byte characters, like having Chinese or other types of things in a particular string, and how that will play out from a size perspective. Just for the sake of time, I won't go over any of these specific details, but just please pay close attention here to what's happening, because the numbers that you get for length and the numbers that you get for size are not going to be what you expect. Okay, and I put some notes at the bottom of the code that kind of will walk you through what that is. But just for the sake of time, we'll kind of shorten it up here and not go over all of those details. All right, so that's about it. Hope that helps explain what strings are. One of the last things to mention is that you want to, be careful with strings. Don't use them around cats. Okay, so that was a really bad joke, but whatever. So thank you for listening, and we will catch you next time.